Deze podcast is powered by ACC ICT, de nummer 1 Kubernetes specialist van Nederland.
Welkom bij een nieuwe aflevering van de Nederlandse Kubernetes podcast. De podcast over Kubernetes voor iedereen. Ik ben Ronald Kers en natuurlijk is met mij...
Hallo Ronald.
Jan Stompors, de...
Solutions Architect ACC ICT.
Ja? Van ACC ICT.
Oh ja.
Wel iets prominenter
Dat mag
uitgesproken
mag
worden.
aanwezig zijn.
Ja, tuurlijk.
Dus
De sponsor van de podcast, hè? Powered by.
zeker. Hey, KubeCon nog steeds?
Ja. Is
Live
dat?
KubeCon. Komende aantal podcasts. Het is allemaal KubeCon, maar het blijft heel leuk. En druk en groot. We zaten net even te meten. Het is gewoon de hele rij.
De hele rij. Ja.
En er zijn 8 zalen, hele berg. Nou, het is niet normaal groot.
13.000 man, hè?
Ruim 13.000
En
man.
vrouw.
13,5.
Precies.
Dus nou, onze gast verstaat ons voor gemeten. Dus we doen ons best.
Misschien wel, maar... Do you understand a little bit, Carl?
I do. It's just a little invisible wall to Swedish. So it's just a little invisible wall. Yes.
So we have a returning guest.
Oh yeah,
this time.
we like that, returning guests.
We have Carl Moberg van Avassa. Welcome back, Carl.
Oh, thank you so much. I love it. I love to be back. It's great. Feels
So-
great.
The last time was on Dev World, and that was also in the rij.
Was on TechX.
Oh nee, TechX, ja.
TechX.
TechX.
Okay.
Yeah, it was.
TechX, yeah, was also in the rij.
Was also in the ride, yeah.
Yeah. Everything is in the rye.
Yeah, it's a big venue.
Yeah.
It's really big, and
It's huge.
just saying the KubeCon is really huge. It's the complete rij.
The whole venue.
The whole venue. You can get lost here.
Yeah, but can I also say that the signs are awful? The signs
Yeah,
are awful.
well, of
That's
course.
one feedback I'm going to give to the.
Yeah, I'm a
Except-
CF ambassador, so I can
Yeah,
take that.
you
to
should.
heart
The
and,
signs. The signs are
communicate it
awful.
back to the team.
Yeah, please.
But
Never mind everything else. Just
the
signs. It's
food
awful.
this year is awesome.
Oh, good.
Did you
I
get the
didn't.
food?
I no.
Oh.
Not yet. So we were on booth duty yesterday,
Oh yeah.
and we've been busy today. So I'll try it though.
No, yeah, you have not the whole day you can get food. It's only 2 hours,
Mm-hmm.
but it's good.
Cool. Very cool. I'll try
Yeah.
it tomorrow.
But because it's Carl's first KubeCon.
Oh,
yes. Yes, it is. Yeah.
Yeah.
So I'll take every
So
advice
why
you can
is
give
it your first KubeCon? So start off with a question now, right?
As you guys know, the reason is that we haven't really thought of ourselves as a solution appropriate for KubeCon because we don't use Kubernetes
dun, dun, dun.
in our platform, right? So we've literally held back just because of that. You could ask me whether, me as a technical geek, why haven't I been to KubeCon? That's a better question. I don't know why. It's a really cool event. I really appreciate it. Apart from the fact that I work for Avassa, what a great event. Amazing.
Yeah.
And what I really like about it is that both the major, but also the small players and the open source people, they bring the actual technical people, which is in wild contrast, as you guys know, with some of the other events where it's mostly, sales and product teams. Here you get to talk to the actual engineers.
Yeah,
which is
you've got
really cool.
for all open source projects. You've
Yes.
got a complete floor with we just went 25, 30 projects.
Yes.
And all the technical people are there.
Yeah, the committers, the
The commits, yeah, the actual
core
people.
Yeah.
And then so if you want to know about Prometheus or Flux or something else,
yes,
just walk up to them.
yes, and that's what I've done today.
Okay.
Because my booth duty is over, so that's what I've been doing. Actually, just going, through the open source.
Oh, that's
Really cool. Really,
yeah, and everybody's open to talk to you and open to share knowledge and open.
and show their code.
Yeah.
Show their YAML. There's a lot of code showing here. Yeah.
As geek is that's awesome.
Absolutely. Yep. No, so I love it. I it's great when you have that little sense of regret. I should have been here earlier, but that's maybe also the sign of the perfect timing. That you have a little sense of.
That's
So,
true. That's
yeah,
true. Yeah, because yesterday there was the On Edge day.
Yeah, Kubernetes and Edge Day. So not only is there a massive main KubeCon, but on the Monday there's what's called co-hosted events, even geekier, even more narrow stuff. like ArgoCon and, all these observability con and all these things. And one of those is actually Kubernetes on Edge Day. And that, of course, is a very nice intersection of our interest in Edge and, automation in general and containers and all that kind of stuff. So eventually we figured we should just go. We should just go and talk to people and listen, hear them out, and also learn quite a bit. So that was our first, and we had a full day. I mean, you get a little table, you get a TV, you get a roll-up. So it's pretty basic stuff. You get to bring a lot of things to give away. And then you get to talk until your voice literally caves in. And we were 4 people.
That's how we also feel.
You guys know about talking until your voice caves in. And we were 4 people, and I think all of our voices kind of gave in at 3 p.m. So it was a terrific experience. Really, really cool.
So we first met like almost 2 years ago,
Yes.
I think maybe.
But yeah.
So if you look back at the first time we met and we had the conversation about Avassa, and you look where you stand now at Avassa, what has happened in those 2 years?
Yeah, so I mean, as you can imagine, the main thing is that generally speaking, the market knows more about what edge computing is. I mean, we founded the company 5 years ago, and the booths that we were in at that time, people would walk in and ask, what do you mean by edge computing? Tell us what edge computing is, and tell us what kind of problem that could solve. Again, now we have events that are named Kubernetes on Edge Day. We have people with edge in the title. So just the general maturity.
Edge in the title.
Yes. Yeah, you should collect those. I have a collection of those, that people that literally have edge in their job title.
Could you give me an example? Edge in the title.
Yeah. So, I mean, people talk about themselves as edge infrastructure engineers.
Oh.
Things like that. Even though some of the verticals have more like, so if you talk to someone in retail, they're usually more like in store. But what they mean by that is the edge or whatever is running inside.
You can only use Microsoft Edge when you use.
Right, there you go.
Oh.
And the only browser you're allowed
I don't want to
use.
be that.
You don't want to be that, or do you want to be that?
No, I don't want to be that.
No?
I don't want to use Microsoft.
It's just
okay.
that's a Chromium engine, but whatever.
No.
Yeah.
Yeah, that's
That's a side game.
my
Yeah.
opinion.
Yeah.
But yeah.
No, so that's a big one. I mean, the general maturity and understanding and I'm going to make a promise to you now that I will be very careful with using the term AI, but I'm gonna burn one now and say that there's a whole slew of ideas of running AI at the edge, which has given like a massive push or tailwind for running applications closer to the sensors, to the cameras, or whatever they're doing. So that's a big one, is that people understand that not all AI will run in the cloud. So that has been almost a stress factor for many of the people that we talk to, is that we have to get this up and running at the edge for various reasons. So general maturity and a little nice push from this almost hysterical AI age that we are in.
Okay,
Yeah.
nice. But you also had some positive effects from the podcast. I saw your
Oh
blog
my God.
and
Yes.
stuff.
Yeah, and I will say that one of the reasons that we could gain the courage to come here, because of course coming to KubeCon without having Kubernetes as a central piece, even though we have integration stories and all kinds of ways we interact with Kubernetes, is a big thing. And the outcome, let's say, or the effect of you guys' fantastic podcast was that we literally had people calling me or, contacting me at LinkedIn saying, I heard this little Kubernetes podcast that seems to be in the Netherlands, and
Those Dutchies again.
And the problems that you laid out matches our worldview or our experience perfectly. So we need to talk to you about alternatives. So from our vantage point, that gave us then there's probably more people that are at a point where they say, okay, we leaned very hard on a very specific way of solving this, using Kubernetes as kind of invariant core solution. And there's a lot of struggles around that.
Yeah.
And they are now open to saying, okay, maybe we should at least look at other ways of doing it.
Yeah.
So that was a very nice effect. I think I gave you the count last time. I think we have 4 customers now that came to us through this. That's the very positive.
Yeah, maybe you work with solution partners.
There you go, and then you will cover the entirety, so you can cover both bases. That's been very interesting, because it's not a super intuitive thing that if I talk about alternative things on your podcast, people would then latch onto that and say that's interesting. Yeah. So that was again also something that gave us the morale to come here and say, if that's in your listener base, then surely there are people on the show floor here that feel the same.
Yeah.
Yeah, cool. So we had some interesting conversations with people already about also we were talking about edge, a normal edge, and the far edge.
Yeah.
And it was very inspiring. What is exactly? What do you understand about the far edge?
As a representative of the edge industry, I apologize for the fact that the whole terminology is absolutely burned to the ground, because you will find that you can talk to your favorite analysts, you can talk to the major vendors, you can talk to the journalists, and they will use different terms. So apologies for that. There is no stable taxonomy yet. What I usually do, just to give you another one, is to talk about so the way we describe this is that edge is a side effect of the fact that IoT kind of ran out of gas. When we hit the market, mostly of what was happening at the furthest part of the infrastructure was that there were IoT devices. And what people usually mean by that is that it's an embedded system with some sort of sensor or more than one sensor, temperature, video, LiDAR, whatever. And they took that data unfiltered, sent it to the cloud. When we entered the market, that was the norm.
Yeah.
Suddenly we saw like a resurgence of a general compute platform. So like an industrial PC. So away from the kind of embedded systems that ran Linux. And that they wanted to co-locate with all these sensors to collect data from several sensors, do something to that data, and then pass it to the cloud. So when I talk about edge computing, that's what I mean. That's the first general compute hop after the IoT and after the sensor. And then just to add to what you said, in many environments, there's another step up that's still distributed.
The far edge.
The far edge, or top of factory, manufacturers love to call that. Like they have half a rack in a carpeted room. So they have the first industrial PC by the machine. And then they have in a carpeted room in the back of the factory, they have a half a rack of something. So
or a PLC? Is that a far edge?
Could be. Or did you say PLC?
Yeah, PLC.
Oh, PLC is very far edge. That's the kind of IoT. That's the actuators. That's what makes things move, right? Yeah. So that's more to me. That's more like there's sensors to read things, and then you can write things back to the physical world. But
are we not getting more compute on the PLC side? So if I look at the factory,
yes,
you've got factory machines. They're ran by PLCs, and PLCs are computers, really small, programmed for doing one thing.
Yes.
Yeah, it's open, close, this thing, and in millimeters.
Yes.
But nowadays, those factories are gonna manufacture more things on the same line, or need to switch really fast.
Exactly,
So,
repurpose the line.
Yeah, repurposing the line. So those PLCs need to be reprogrammed every time.
Yes.
But they also need to recognize probably that bottle is not round but square.
Exactly.
So they need intelligence also. And I'm saying
You're getting there.
AI in the PLC, because they need to recognize that the bottle is maybe square and not standing right, and I have to push it right, and so on and so on. But it is then that the far edge computer needs to be smarter and bigger and needs to be maintained differently.
Yes. Oh, yes.
And needs more compute.
It needs more compute, and the Raspberry Pi, not 0, but the
5.
version 5 needs to be in there instead of the 0, just to keep it.
So I mean, it's a very specific use case, but it's one that I've been really swimming around in for a while now. The biggest thing that's happening now is that if you look at a traditional PLC, you're right, it's usually a microcontroller.
Yeah.
What's happening now, if you look at and this is getting geeky now, if you look at the major PLC vendors, there is about one German company called Codesys. Most of the other large vendors actually use the Codesys PLC software. They are virtualizing and containerizing the PLC itself, the software PLC. Yes, very, very cool. So they're literally, for very forward-looking manufacturers, they're now, and robotics vendors, they're taking the PLC software out of the hardware PLC, putting it on Linux, and then they have Fieldbus or other kind of real-time connectivity to the actual actuators. So they are now moving the PLC software to the IT domain, which is the whole IT OT thing. So if you look at that, what's actually happening is that our customers usually start with putting very basic features into their industrial PC that reads stuff from the machine. Then they realize that they have to normalize because all the machines have different formats. And then they start thinking about what can we do? Can we do predictive things here? And then they get to the point where they go like, okay, there's a feedback loop here. And then they start looking at the virtual PLCs and to put that on the same industrial PC. And this is a very interesting like story that we see over and over again. And that happens on like small form factor, to your point, PCs that are usually mounted close to the machine, but it's running full-blown Linux and usually has Python and some sort of MQTT broker and some inference engine. And the next step is normally to take the PLC software and put that on the same device.
Because they need to be close. The latency is a bit of an issue.
So there's no way you can even put that on the like a carpeted room or top of factory. You need to have it co-located with your machinery or on the robot, which is a very common thing as well.
Yeah. And we just spoke with KubeSolo.
Yep.
And they said, yeah, that's my solution is perfect for that.
Yeah.
And the whole world is going to operators and Kubernetes API driven.
Sure.
And he was saying, yeah, why are you gonna develop it yourself then? Because we have a solution to run Kubernetes in small form factor on that single machine in a low memory space, and everything is going to Kubernetes. What I like, of course, but and why are you going to develop it yourself then?
I mean, so if we step back and look at it, right? If you look at those applications, they're very simple. Usually single container, maybe 2 containers. They don't have much in terms of, there's just no way. So the general terms that have made Kubernetes successful, things like horizontal scaling.
Yeah, but he was not talking about that.
Right.
The greatest thing he said.
Yeah.
You run 3 of those machines.
Yeah.
And they're single node Kubernetes.
Yeah.
And then put a load balancer before that.
Yes. And I've never seen that in a manufacturing environment.
No, I was.
Yeah.
That's always one, and if that breaks,
Exactly.
Somebody pulls that thing out and puts everything in.
Exactly. And also you have things like in most manufacturing environments, and maybe I'm over-rotating on that now, you have very, very strong security practices. So you have something called ISO 95 or Purdue, where you have layers of DMZs. Things that there's literally no, support for that in Kubernetes. You will have to reinvent all that yourself. So we come back to my old stories, like Kubernetes is a way, in this case, to just start and stop containers. And then there's the rest of the 95%. Is how do you actually make sure that your call home process can only start from the production cell to the central. You can never do anything in the other direction. There are NATs and firewalls all the way. So now you have to build something in Kubernetes that calls home. And now you need to access, for example, give people a terminal into the shell in the container. That doesn't come for free with Kubernetes. You have to reinvent that. Now you have to think about how do we actually keep logging and telemetry local, because you can't send that centrally. Now you have to have a service for that. Now you need your secrets local, right? Because if you lose connectivity, your applications, so you have to have a local secrets vault. Then you have to have some sort of configuration management. So you need to have that local. So now you have Kubernetes, and you have somewhere between 10 to 15 different services.
HashiCorp Vault, and I was sealed secrets.
Yes.
And I was thinking about...
so now you have to manage Kubernetes, all these things, and then there's a new version of HashiCorp Vault. Now you have to upgrade Vault in all locations by hand to make sure that it doesn't actually break the configuration.
Yeah, you've got software for that.
Yeah, you get software for that, but then you have to invent that. It doesn't come from Kubernetes.
No,
that's not what Kubernetes gives you.
No.
So Kubernetes, again, is a small piece of the stack, but it's not sufficient. It might be necessary for some people, but it's not sufficient. So you're now tasked with, when we talk to people at the show floor and we ask them, how do you manage all these Kubernetes instances that you have running? And they say, we invented that. Is that a good thing? I don't know. For some people, it's really cool to build a centralized orchestrator that can do all these things at scale over time. For other companies, it's like, why would we invent something just because we want to keep Kubernetes at the edge?
Kost het beheer van Kubernetes je veel tijd en expertise? Maak kennis met ACC ICT. Zij ontzorgen je volledig met managed Kubernetes diensten op elke cloud. Gecertificeerde specialisten zorgen voor compleet beheer, 24/7 support en optimale beveiliging. Jij kunt je focussen op je core business, terwijl je Kubernetes-omgeving in betrouwbare handen is. Manage Kubernetes van ACC ICT. Jouw zorg, onze expertise. Bezoek accict.com.
And that's kind of the tension field that we are in. We know of at least a couple of companies that are very successful with Kubernetes at the edge. And they spend massive amounts of time and money and talent to keep it that way. And then there's a whole slew of companies that can't really afford to do that because it's not a strategically important thing for them that it's something labeled Kubernetes running at the edge. The more important thing is that their application teams can reliably deploy applications to the edge, monitor them, upgrade them, all those kinds of things.
Yeah, I've got a video of that. My video was, what's the most important thing of your company?
Right.
What's the
The applications.
That it works.
That it works. Yes.
Yeah, that's.
Yeah.
I don't mind if I don't like Windows, but if you run Windows, Linux, or Kubernetes or something else,
Exactly.
the most important for your company is that your software works and that you can support it.
And I mean, this is one of the big takeaways here for us here as well, is that slowly but surely we see how the application teams are going to eventually, like, people are slowly understanding that the value of what's happening in the retail store or by the machine is the software running there, not the infrastructure. See what I mean? So as we hear more and more how application teams have a deeper say, they are getting called in or getting help. They get to be involved earlier on in how do we actually design this infrastructure. And my take, even as I try to discount my bias, is that they don't care too much whether it's Kubernetes or Docker or Podman. As long as they're given the tooling, as long as they're given the opportunity to deploy. And those are some of the things that are really cool on this show floor here. Like, what's the standard packaging? How do we give the right access rights to the edge? Things that are pretty far above, whether it's actually Kubernetes of a particular version or Docker or Podman. So that's kind of, I think that's where the direction of the conversation is. Some of them will gravitate towards Kubernetes solutions. I happen to think that many of them, for many reasons, will be open to conversations about stuff that doesn't have pull with it kind of the complexity maybe of Kubernetes and the
but that's really what Kubernetes is a kind of Linux. Yeah. So you've got the core, that's Kubernetes, and then you have programs on there to
you build on that.
Yeah, you build on that to make it complete. Because I manage Kubernetes, but it's Kubernetes with 13 extra applications to keep my containers running and happy and to see what's happening.
Yeah. So how many applications are you running on that cluster?
Yeah.
I just give it a 1, 5, 10.
No, around 13 for managing, and then for the customer, that's 20.
Isn't that ironic, though, that you run almost as many applications
but
as your customers?
If you look at Linux,
right?
Do you know how many applications that is running?
Yeah,
because you've only have the kernel, and then thousands.
Yeah,
so that's
probably thousands. Yeah.
So that's the way how Linux is built, and that's awesome because every application does its thing the right way, the best way.
Yeah.
If you look at Windows, it's one binary.
No, so good point. I think, when we fired up one of the on-prem solutions from one of the hyperscalers down here, their Kubernetes solution, when that turned up with, just default settings, they had 26 containers running on Kubernetes before we started a single container. Now we're talking about doing this on a single industrial PC by a machine. And then again, you're a good CVE tracker, right? So if your Falco has a CVE, now you have to upgrade that. And you look at the changelog, they've changed the syntax of your configuration of the Falco. So now you have to rethink how you configure things because it interacts with your other things.
Yeah.
Now you're in for it.
If you do that for thousands of machines,
Yes.
then you've got a team running, doing that the whole day.
Yeah.
Because we've got, in our company, we've got a team running, doing all day Helm upgrades and Helm changes and for all the applications which we are running for our customers.
Yeah.
And that's a lot.
Yeah. But I think that's the difference. I think doing things that are actually related to the applications. That's one thing. You could argue that's actually value creation, if the application teams are doing it. But managing your 13 applications and keeping them upgraded, keeping their configured coherently.
It's not differently than doing Linux YUM upgrade or patching.
Right. Which is horrific, right? That's just a horrible experience.
Or running a new container.
Yeah.
That's the same thing.
Yeah. I don't know. I mean, I don't particularly like YUM upgrade. The whole package manager stuff is interesting to say the least. But yeah.
So how do you solve it with Avassa then? We can then look into the nitty gritty and all the containers and stuff and all the specific. But I think that point is quite clear.
Yeah.
So if you look at it from your point of view, Avassa, how do you solve that problem?
Yeah. So implementation wise, here's what we wanted to do is to allow application teams to say, okay, I'm looking at the edge. How do I want to deploy my applications at the edge? So we came up, this was a couple of years ago when we started the design of the system. And we think that they're going to need three things. First, they need to understand where are my hosts? What are the hosts that I can deploy to?
Yeah, we can draw it out. You have 3 hosts, right?
Exactly. A typical list of hosts. Here's my available hosts. And what they want to know, generally speaking, is that what can these hosts do? And do usually means is there a GPU on the host? It can also be things like, where in the world is this host?
Yes.
It can also be if it's in a manufacturing environment, is it in the production? So, things that are generally useful to understand as an application person. So you get a list of hosts that have labels. And then, of course, you need to define your applications. You have to tell any system, here's an application. And of course, we can steal liberally from the container world, from compose and pods. My application consists of a set of containers, maybe a virtual machine, maybe a model file. So they need to be able to configure that in the system. So those are two things that are really hard to avoid. And then the third one that we think is even the most important is to say, for this application, for this version, I want to run those applications in the following locations.
Sure.
And locations are not normally just the name of the locations, but things like in the northern region, if you're a retailer, and only if the store is of size medium or large, and if there's a GPU, because it's an application with GPU. So that's the abstraction that we provide through our system. It's okay, that's what application teams want to manage. And then we allow the system to figure out how to start the applications in the right places and then make them monitorable or manageable. How do we, get metrics and all those kinds of things? And when we started building that, we realized that there's no actual point or need for Kubernetes at the bottom layer of the edge here. We can easily do that with Podman.
Sure.
Or Docker.
Spin up the containers, right? So
Spin up the containers, set up the networking between them.
Are you still using containers for your applications?
Yes. So yeah. That seems to be very stable. I mean, the AI applications that our customers are bringing, the WASM applications that our customers are bringing, the model files that they're bringing, even, and this I think you will both enjoy, well, you actually know this already from the Kubernetes world, I guess, is that we have customers that have this one VM that they have to keep alive, because there's some weird hardware. And they stuff the QCOW into a OCI container.
Yeah.
So we just, allow them to say this application actually has 2 containers and a VM. And so we can use KVM to just run that. And we can do that, again, based on Docker or Podman on any Linux, any normally behaved Linux, without, all these things running on top of a Kubernetes cluster, which to us is super compelling because then we can take care of managing the one agent, that actually does all these things.
The monitoring and observability.
All that. And also a local container registry at the edge, of course, local logging endpoints, local secrets manager, like an integrated vault. All of that stuff we can do with a single container application that runs at the edge that we can also upgrade. So you don't even have to care about that, which means in the ideal sense that the IT team doesn't actually have to care about, Kubernetes versions and supporting containers and all that kind of stuff. And the application teams get self-service, meaning that they can deploy to the edge without actually without involving the IT teams, which is kind of the holy grail for most of our customers, is to allow application team self-service. So you don't have to have 5 meetings every time you deploy something and describe to the IT team that these are the locations that we want to deploy to. We don't actually know what's running there, but can you please do this for us? But instead give them like a backstage portal, or as we actually showed, I think I told you guys before, we showed today, or actually yesterday, a cross-plane Kube API extension that allows people to do this, but with kubectl. So using Kubernetes RBAC, you can give your application team self-service through a Kube API, but to the edge by talking to our REST interfaces. A little bit of like a gimmicky thing, but really to prove that this is probably how we, well, not probably, this is how we think you should think about this. Give your application teams just the access that they need with the right RBAC policies and all those kinds of things, and keep the IT team more as a platform.
Yeah, and if you want to run your Helm charts.
Exactly. Or kubectl and actually a Helm chart with components both at the edge through us and in a local cluster was key or core to the demo. Not sure anyone's going to run that, but just to show that this is probably how you should think about it.
Maybe because I was listening to a podcast. I listen a lot of podcasts.
I can imagine.
Yeah, I think, and foremost technical, that G6, the cell towers, and you've got G5, 5G, sorry.
5G, yeah.
And now you've got 6G.
Yes.
And they're going to deploy AI again. Now, AI,
you said it.
Yeah.
This time.
AI
That was strike 3, by the way.
at the cell towers.
Yeah.
So they're going to deploy machines on the cell towers to do AI there.
Yep.
And I could imagine that they're doing compute also in the data center.
Yes.
So could be a valuable solution that you could deploy your application on 2 sites.
Absolutely.
On different sites.
Yeah.
My follow-up question, different one. You said you're updating your application on the edge.
Yes.
How does that work?
So it's a containerized application.
Yeah, of course.
And it's built in a way that allows for, let's call it hitless upgrades. So we use certain technologies. I think I've told you guys this before. We're a pretty heavy user of a programming language called Erlang. That's what we use. It's a language for distributed fault-tolerant systems. And by the design of that application, and of course how containers work, we can hitlessly upgrade that agent without losing the state of the local cluster, which is really key for us, right? Is if you upgrade it, it needs to it needs to remember what it did before it got upgraded. So,
of course.
Yeah. And what it allows us to do, again, is that since it's a single application, we can version the configuration of it, right? So it doesn't have to interact with, 52 other components. So we can keep things like tenancy, we can keep things like certificate management, we can keep things like who's the leader of the cluster. We can keep all these things in a single coherent replicated state with that application instead of, relying on, one of the things that we appreciate or that we talk to customers that are open to other solutions than Kubernetes is that there are all these projects that they need to run on the cluster. And the projects use different configuration file types. They have different syntaxes, right? And it's really hard to figure out the actual interaction between, let's say, your Cilium and your OPA, or, your Falco and your, what does it mean that I've configured this to behave like this and the other one to behave like this? One is in YAML, the other one is in environment variables, and what happens if they add a new feature or change the feature? How does that interact with the other 13 components? Becomes super complex, and it's not a formal exercise. It's an experience-based exercise. So you're doomed to catch that probably in your canary or, before you deploy. And of course, one of the benefits of saying, no, we'll fix that in one vendor binary, which to speak honest, is what we do. Mm-hmm. We can version that configuration and the behavior in a single application. So we avoid all that complexity, which has security implications, of course, which definitely has operational implications and complexity implications. So that's one thing that keeps makes life easier for us. So we can say that we can manage the life cycle of that.
And do you have access then to all those IT machines? How does it work? You said it's a container. So does it download itself?
Yes, exactly. Yeah. Now,
So you will get a new version out,
this is
and it will download itself, and in the improper time, and it crashes.
there you go. So this is an entire topic. No, of course. We give our customers a lot of configurables around scheduling. I'll give you one fun thing, which is to say that we found out by working with customers that it's easy to say, we'll just add a maintenance window, let's say between 9 p.m. and midnight. Turns out that we have customers that are running many time zones.
Yeah.
So that actually doesn't happen at the same time across time zones. So you have to have time zone dependent, scheduling, right? So you have to keep track of that. So it's a whole topic on itself, actually. This whole operationalization of the edge is very, very interesting. And that's one of them. Of course, when we launched this feature and when we launched the solution, we thought, well, they'll just trust us and they will just allow us to change their, management plane whenever we feel like it. And of course, that's not true. So we started adding features for this around 3 years ago. So you can schedule things, you can hold back releases, you can do it, in certain time slots and all those kinds of things.
Okay.
Yeah.
Yeah.
Yeah. And
You go first.
yeah, I've got a lot. But are your images signed then also?
Yes.
Are you supporting signed images? Because I think that's really important, and
Yes.
a lot of people forget.
Oh, I got. Yes. Yes, for our own images, yes. The bigger and longer story is that I think this will eventually become even more important. Not so much, well, we have it for our stuff. I will say that the general experience from the users that we have is lagging what needs to be happening, which is signed and verified images.
Yeah.
And eventually confidential containers also for the edge stuff. And that's another whole topic that's so interesting around how do you authenticate and authorize non-human entities, things like Spiffy and JOTS and all those kinds of things. But this is happening right now. Actually, one of the topics that we really have enjoyed talking to a lot of vendors and open source projects about here, because this is going to bite people very hard very soon, unless they start taking it very seriously.
Yeah. That's that. And also, do you provide the images for the containers or the?
So we don't provide the images for the containers that people deploy, but obviously we provide the container images for our own agents. So that one we have control over and we sign and verify. But, it's trying to understand where this whole signature thing with SBOMs and all that is going. How do we integrate with things like Trivy and LaunchStart and all those vendors? There's
Zero Date Privy. That's my new name for that.
Yeah. Yeah, it must have been interesting to work for Trivy for a couple of days now. Yes. Yep. So we care deeply and we try to follow and understand where our customers want to go with this.
Are you doing then also trivial-like operations or Falco-like operations? So, not yet.
Not yet. And a good point, not yet. I mean, most of I come back to this. Most of the time we spend with our customers right now is almost like following them as they build operational experience of what it means to run containerized applications in thousands of locations. None of our customers came to us and did their first deployment with 5 years of experience, right? None of them had any experience because there are very few people that can say with a straight face, I've been running containers at the edge in production scale for years. So for us, from a product perspective, it's about really following them. Like, how is this panning out? So, and we talked about like, how are they going to eventually package, AI model files? Mm-hmm. There's a whole slew of ways of doing it.
Yep.
And we're not going to take a bet on one of them yet. We're going to work closely with customers. Same thing here. How do you provide a chain of trust all the way out to a very physically exposed edge?
If I think on PLCs, back to that.
Yeah.
The chain of trust must be very, very, because when that machine gets hacked or something else, it's gonna kill your business. Or kill people.
And actually, I mean, some of these like machine builders and certainly the customers of the machine builders are literally like nation state critical infrastructure. So yes, that attack surface, that attack vector is underappreciated as with most of these things. And the good thing, I guess, at least the energy that we pick up from the show floor, is that there are enough smart people that are now actively thinking about it and doing something about it, that we at least see some energy coming in. And then, of course, we can, work with our customers and pick whatever kind of comes together as the most reasonable way of doing it.
Yeah. What hooked me, what you were telling, you talk about and we manage and we do this.
Yeah.
Is it like a SaaS solution what you provide, or is it also on like an on-premise self-managed
So by default, and actually at this point, all our major customers, and we have some very large customers, actually consume our management plane as a managed service. So we actually manage the life cycle of the part of our system that provides the web UI, the CLI, and the REST API, and nowadays also an MCP, of course, because AI. So yeah, that they consume that as a service, and we host and run that. So absolutely, the chain of operations, including upgrading both the management plane itself, but also the agent, most customers allow us to do. Now we have options, and we of course have customers in industries that are very regulated or legally bound to have.
Yeah, because you give some. It feels like I give you the keys to my infrastructure, right?
Even though we can show them that they haven't, because they have the key, and don't lose the key. Of course, there's always going to be that in the back of their head.
Yeah, and
we can fully appreciate that, and we do offer like on-prem air-gapped if they want to, or running their own VPC if they want to do that. But it's mostly, I would say, a trust and security issue. And if we can show them that, we're ISO 27001 certified, which was a very interesting exercise.
Oh, yeah?
Yes. Okay, I'm stretching the word interesting a little bit.
Yeah.
It was interesting afterwards. So, and that we have, a decent security posture, meaning that the communication between the edge and the actual orchestrator, or management plane at least, is safe enough that their security people don't freak out. That usually changes the conversation, right? To say, okay, now we can consider actually using your hosted model. So it's been relatively successful.
Oh, so you have like the option. You can run it in your environment.
Yep.
But if I have my own hosted environment, you can also deploy it there.
For sure. Yeah, and I used a lot of words to say that a surprising amount of customers, after some trust issues and some security due diligence, tend to stay with us managing it. So that's the most common thing, is that they allow us to manage it.
Yeah, because
that's why I use
what they always say about Kubernetes, for example, so I can take my cluster somewhere else.
Yes.
If I don't want it in the cloud, put it on premise or
Yes.
In a figure of speaking.
In an ideal world.
If you don't use cloud environment, and we saw with the deprecation of Nginx.
Oh, yeah. That's a good one.
Oh, yeah. Okay.
Yeah.
We installed traffic. Traffic everywhere. I have to say traffic.
I think that's perfect.
But yeah, that's a great tool, but it runs differently on Google.
Yeah.
And on Azure.
Yeah.
And on-prem, and
so there goes the whole story about
that's
independence.
It just adds a little nuance. Let's just say it adds a little nuance.
So it's a little nuance, but the connectivity outside is always a cloud specific thing. But everything in Kubernetes, if it's in Kubernetes,
that's a good point. That's like internally coherent.
Yeah.
Yep.
So, what is your biggest?
Oh, great. What is our biggest fuck? I mean, operationally, like
I bleep that out in the editing. Right?
Yeah.
For the international speakers, I need to bleep that out.
Yeah, sure.
Your biggest beep.
So you mean like in terms of operations?
I always love to hear the success are fine, but sometimes you want to hear the other side also, right? The learning experience.
Yes.
Maybe that was a better.
Okay, good. So there's a built-in tension between two things. One is that the life cycle of certificates are shrinking because people don't want long-lived certificates.
24 days?
24 days. The expectation on systems like ours is to allow hosts to be offline for a long time.
Oh, I can feel where this is going.
You can guess what happens if your host stays offline across your certificate lifecycle. That becomes a problematic situation. I know this is a little bit of a chicken option here because there's not too much as a vendor we can do about people doing that. But let's just say that puts hosts in a very complicated situation. I mean, as with any edge environment, your worst nightmare is disconnecting in an unrollbackable way, so that you have to go on site and do something
On the other side of the world.
on the other side of the world, literally on the other side, or at sea, or in the jungle,
Or in space.
or in space. Absolutely.
Well, it could be a nice adventure.
I was reading about data centers in space and what you need to do for that and how, and that's really interesting.
It is super, super interesting. I love it's super interesting, and I love how edge computing, as in the general sense that we talked about before, is becoming so common. Things that used to be so much like closed proprietary embedded systems are now it's just an x86 PC with Linux flying around in space times 10.
Yeah,
running containers.
It was running the forbidden word in AI, in space.
Right.
The forbidden AI word in space. So it was really cool running an NVIDIA box and running that in space. And what you need to do for that to keep that running, because power in space is really easy. It's cheap and abundant.
Yeah, of course.
But cooling is a thing, and the space radiation is also a thing.
Yes. Yep.
So, but complete different story.
Right.
Maybe a new podcast subject.
Yeah, okay.
Yeah.
But yeah.
Yeah. To extend my question a little bit, so you have your own solution as a SaaS.
Yep.
How do you look at the sovereign cloud stuff?
So that for us becomes a little bit of a tailwind, right? Because people tend to think about sovereign clouds. Well, so I think the easiest way to explain it is that the data being created, the actual data that people associate with the idea or the reason to go to sovereign clouds, in our case, is usually at the edge. So you can imagine like 4K video streams inside of retail stores, which, to put it mildly, is a GDPR violation in and of itself. There's just no way you can allow that 4K data stream to get to even leave the store, right? Because it's literally high quality videos of people walking in and out of stores, right? So
it's a privacy consent.
It is a huge private, and also
it's a data source.
It's a data source, and look, you can imagine if you go to a modern retail store or a modern grocery store, and you look at the checkout lines, they usually have a camera, they have a scanner for your credit card, they have a scale, they know exactly what you were buying, they have high definition video of you. It follows you throughout the store.
Of course.
That is just, at least in Europe, that's just insanely private data. That's just PII, up the wazoo. So for many of our customers, that is the little, cloud where you have to keep your data, eventually dispose of it in a provable fashion. Yeah. So it's not so much like where do we have our control plane or management plane. It's rather the data streams that we collect. How do we make sure that there's no leakage or, policy violations or legal violations? So it's almost like they think of each edge locations as a small sovereign cloud. And I think what's happened is that the whole idea of sovereign cloud has really accelerated that. So people understand better than to just send that video stream to whatever Amazon, zone or Amazon data center you're running.
Open bucket on Amazon.
Yeah. Right.
Yeah. Yeah, laugh about it. But I think if you go look for it, a lot of buckets.
Absolutely.
Now, there was a time that if you created a bucket in Amazon, the restrictions weren't there.
Right.
And that's changed now, but that's
yeah.
Azure had the same thing.
Yeah. Yes. Probably.
So, yeah.
Yeah. Do you still have questions left on your sheet? Because it's a long list.
I'm pretty tall. The list is long.
How do you see Avassa competing or integrating in the long term?
Mm-hmm.
With Kubernetes.
Yeah.
Sorry, I forgot a lot.
I'm just waiting for it.
He's
eventually going to say he's such a dramatic person.
Dun, dun, dun.
Yeah. No, I truly believe that there are. So talking to someone today over lunch, a guy who has a lot of experience with Kubernetes, I would even argue that he's one of the more experienced people in the Swedish technical ecosystem, he had interesting ideas about how there needs to be abstraction layers between, the edge substrate or the edge environment and then the data center environment. He was very much into, let's look at the Kubernetes API as the kind of the way they talk to each other. So I'm very interested in, and I will spend a large day tomorrow to think about and talk to people about, like, but all our customers have applications, and the applications, they have two types of components. One is running at the edge, and one is running, in a central environment, where I think it's very natural that Kubernetes is, of course, the abstraction and the mechanism for this. And they want to keep this coherent, right? They want it to be a single release. They want it to be monitored as a single thing. They want it to be upgraded as a single thing. They want it to be, security checked as a single thing. And that drives a lot of thinking. Like, the simple way out is to say, just make it 2 hooks in your CI/CD and then collect data and correlate. But I think there are deeper and more interesting conversations here about what if you were to look at the central environment from the edge, what would that look like? Probably like a kubectl API or a kube API. And if you look at the edge, of course, we think the abstractions that we do are right. Maybe that is also through a kubectl or kubectl-like API. So I think the deeper integration between the central environment and the edge environment in both lifecycle management and monitoring and observability is going to be the exciting part of the development here, because I think they should behave as a single thing, as a whole.
You're gonna send your metrics to Prometheus?
Absolutely.
And
I mean, look at things like, we talked to a small not a startup. It's an open source project called something I forget now. It's an extension to it's Microsoft Azure doing it. So it's an extension to, they have a language called Bicep. I don't know if you guys have looked at it. This is like Bicep++. Apologies for forgetting the name of this project. They were really interesting conversations where they have a means of expressing, like, the entirety of the resources related to one application, independent of whether it ends up on the edge or whether it's like, so a kind of a single way of expressing that can then break down into different, like, context specific manifests. And I would love to see that also for telemetry, right? I would love to see that for observability tools and for break-fix tools, right?
Like OTel.
OTel?
Do you have an OTel endpoint?
Yes, we do. Yes.
Cool.
Yeah. No, I mean, these are implementation choices, and that's, I mean, those are pretty, I wouldn't say trivial, but pretty easy to add, right? So of course you can consume our metrics as OTel. That's nowadays it's becoming the universal connector.
Yeah.
But trying to, how do we express applications needs in a way that actually covers both the edge and the central environment, and how do we then monitor? How do we then observe? How do we then actually break fix those things? That's, I think, how that happens is going to define our kind of technical strategy going forward, because we think people should eventually forget that they have Avassa. See what I mean? Yeah. We want to be part of the infrastructure that's hidden behind the abstractions and the tools that they use, as much as I think people should also not spend too much time thinking about the fact that they have Kubernetes in the data center.
Just
exactly right. Exactly right.
And thinking about that, are you planning to go open source in the future?
Ooh, we've had that question many times today. Right.
Yes.
And as you can imagine, right, this is a very, like, an intuitive reaction from people here. For us, and it's, I mean, if you look at the challenges that many, initially fully open source companies have with literally their finances, it makes us think before we would do that. And it's not because we don't think it could be useful for many, in many ways to make it open source. And we have, in a system like ours, I mean, we have so many components. Like, we have a distributed registry, we have a distributed secrets manager, we have a distributed scheduler. There are bits and pieces here that may make sense to open source. We do support open source. For example, we are part of the Erlang Foundation because we use Erlang. So it's not that we're not fans of it, but it's getting hard. I would say it's getting more tricky to understand the path to some sort of definition of success by open sourcing something. I think you have to be a little more deliberate about it. The good thing is that it's all our IPR. We don't have to ask anyone to open source it, so we could.
Oh, yeah.
So we keep thinking about it, and it's inspiring and interesting to talk to people here that have such a deep intuition to ask, like, what parts of these are open source.
Yeah.
And the fact that I have to think for 3 seconds makes me go, okay, maybe we should, let's think deeper about this. So we have nothing against it, but we have no current plans to do it.
Okay.
Yeah. Yeah, I came up with something else, but it's outside of this podcast. So I will ask Carl later on. And if that's interesting for a podcast, we do a follow-up on that.
That's amazing. That's great. I like that.
It's about gaming consoles, and that's also an edge case, right?
Yes, for sure.
And they update also rollback updates. There's an interesting part.
Yes.
I was just looking it up, like atomic updates and something.
Yes.
Stuff.
That's another thing. We've talked to the projects that we know of that are trying to build a better Linux for edge. That takes away those 2,300 processes that no one in the world at the edge is interested in, like your Whois daemon or whatever it is that's running in the background, and pares it down to the bare minimum, including a container runtime. So that's another topic that we are very interested in.
Dual partition update,
updates, exactly.
Stuff.
Yeah, this is another topic I can go crazy on.
Yeah,
and the problem for us...
That's how my mind works. So sometimes it flies in like this.
The problem for us is that we need transactional upgrades of the operating system, just like an SQL database. If you look at the way that your YUM and DNF and apt-get and all that has worked, it's been the insane amounts of side effects, no provable rollbacks or anything like that. So that, I think, is a very fundamental thing that needs to be fixed. So when you do an upgrade of an operating system, you need to be able to say prepare, dry run, and then commit, just like you do with databases. And there are some bits and pieces here. You have your Talos, you have your RPMO.
Gensels are doing this for a long time already.
I know. So
success, eh?
Yeah, with some success. And so, as with many things in computer science, it's not that people have already solved it, but for some reason, people feel like they should reinvent.
That's basically containers.
No, but that's a really closed ecosystem.
That it is, but they've solved it. I mean, there are patterns, not patterns.
Yeah, if it's closed, it's easier.
Yeah.
So if
true.
If you do, yeah.
No, yeah. Well,
you want it.
PlayStation is basically Unix, and Xbox is basically in customized Windows.
Yeah.
Mm. So you should get people on here and just tell them to fix it.
Yeah.
Get some really clever Linux kernel or Linux packaging people and just tell them to fix it. Yeah.
Yeah. It's doable.
It is for sure doable. Absolutely.
Wow.
Okay.
Do you have the final question for?
No, you've got it.
He already knows it.
I will sit back.
So, yeah, you will sit back. So, as you know, the final question is always like, how do you foresee the future? And for us in Kubernetes, but I think you already answered it a little. You already answered it about a part of it, like with Avassa and Kubernetes coming closer together.
Yes,
right?
Exactly right. And I think again, I think paying attention to how do we operationalize AI applications. I said it I know it's the fourth strike here. How is that? Should we think of AI applications just like any other application? Or are there particularities with it that needs to be taken into account in the infrastructure layer? Like, how do we actually, with a long background in networking, we had standard ways of doing, monitoring of networking. We have standard protocols for that. There's OTel for like enterprise environments now. What does it look like for, AI application telemetry? That's all over the map right now. So where's that going to go? Because that's needed for the training steps. What's an upgrade, a hitless upgrade of a model? What does that look like? So I think, and of course, Kubernetes will be the first environment where people do this, right? So it will have to be solved by Kubernetes probably first. Mm-hmm. And then the experience of that will spread to other parts, including to, I think, the edge eventually. So I think that is something to keep an eye on, which I also think will be fun, because it's an entirely new type of operations that I think will be actually pretty interesting. might actually change the game, might actually change some of the fundamental architectural components of a Kubernetes and of an Avassa or of a Docker or a Podman. So I think that's a topic to keep an eye out on.
Yeah.
And, really talking to people that are now building experience with product deployments or production, deployments of inferencing or whatever it is that they're doing in AI, I think it's pretty interesting.
Inferencing, yeah.
Yeah.
That's a cool word.
Yeah.
Well, Carl, thank you very much for joining us again in our podcast. And maybe we can look in 2 years where we stand on that topic.
I will come back and give you more of my energy and the feedback that we get from our
have to be
customers.
2 years. It could
There
be
you
sooner.
go. Exactly.
Yeah, nothing with AI. But
Okay.
KubeCon in Sweden, maybe sometime.
Yeah, that'd be cool. Yeah. Now, I really appreciate you bringing me on, guys. I really appreciate it.
Okay, well,
thank you.
thank you.
Thank you.
Deze podcast is een initiatief van ACC ICT en wij zijn te beluisteren op onze website k8spodcast.nl via Spotify, Apple en alle andere favoriete podcastproviders.